All right, and we're going to continue our conversations about parallel and now perpendicular lines. All right, so this lesson, you actually did the exploration in class, right? And when you did this exploration, you were started standard 6.3. I can determine if two lines are perpendicular. All right, and you went through the exploration in class to find a relationship, all right, between, all right, the slopes of two perpendicular lines. So let's talk about that relationship right now. So we're going to be on the second page of our notes here. So perpendicular lines are two lines that intersect, all right, to form four right angles. All right, so to intersect to form four right angles. All right, and have opposite and reciprocal slopes. And that was really what the exploration was for, so that you would see this relationship, all right, that two lines that are perpendicular will always have opposite and reciprocal slopes. So what does that mean? The slope of our first line, if it's A over B, right, the slope of our second line would be negative. That's the opposite part. One has to be positive, one has to be negative, and then reciprocal would be B over A. All right, so those are the two ways, or two things, excuse me, that we want to see when we're looking for slope. They have to be opposites and reciprocals. All right, so both things have to be true. Now, the great news about this lesson is that it's going to reuse a lot of the same skills we've already looked at with determining if two lines are two lines are parallel. All right, the difference is now instead of looking for equal slopes, all right, we're going to be looking for opposite and reciprocal slopes. And it's even a little bit easier because we already know the lines intersect. So we don't have to verify, all right, that they have different y-intercepts. So it's a little bit quicker actually than when we did parallel lines. So to do this, we must find the slope of each line. So we identify the slopes, all right, and if we can't identify that slope, we have to manipulate the equation so that it's in slope-intercept form so that we can. And then we can verify that the slopes are opposite and reciprocals, all right? And so one positive, one negative, and then A over B and B over A. All right, so let's just jump right in here. So when we look at problem one here, determine if each pair of lines is or is not perpendicular. So when I look at my first line, right, I can see it's in slope-intercept form. I can see the slope is 3 over 1. Now remember, every whole number, all right, has a denominator of 1, so we want to write that as a fraction. And the slope of line 2, we can see, because it's in slope-intercept form, all right, is negative 1/3. So we can see that they are definitely opposites. All right, so one is positive, one is negative, and we can see that they are, in fact, reciprocals. So these two lines are perpendicular. All right, now, once again, here's our special case of lines here. So the first one, x equals 4. Remember, that's a vertical line. All right, so it's a vertical line. Y equals 7. That's a horizontal line. And if we have one vertical and one horizontal, we always know that they will be perpendicular to each other. All right, now, and sometimes you might need that because the slopes don't necessarily look like opposite and reciprocals because the slope of a vertical line is undefined. And the slope of a horizontal line is 0. So when you write those out, you may not see opposite and reciprocal, but we have a concept too, and that really gets back to this idea here, right? Intersects to form, all right, four right angles, and we know that's always going to be the case with one horizontal and one vertical line. So these are also, in fact, perpendicular. All right, now let's jump to number 3 here. Once again, first equation is in slope-intercept form. I can see that the slope would be negative 2 over 1. All right, I cannot see my slope, all right, right here. So I've got to do a little bit of work, and this is where we work to make it look like slope-intercept form. So I'm going to add 4x to both sides. And so I get 8y equals 4x plus 16. And then I'm going to divide everything by 8. And so I get y equals, and then remember, we always want to have our slopes in lowest terms so that we can compare them. So 4 over 8 reduces to 1/2 and then x plus 2. And I can see that the slope of this line is 1/2. All right, so they are opposites and reciprocals, so they are perpendicular. All right, so moving to 4. Slope-intercept form, I can see that the slope is 1/2. Point slope form, I can see that the slope is negative 1/2. All right, now notice these are opposite. One is positive, one is negative, but they are not reciprocals. So both things have to be true, not one or the other, both things. So these would not be perpendicular. All right, for number 5, once again, special case of lines. Y equals negative 7, all right, is a horizontal line. y equals 4 is another horizontal line. And we should know that if I have two horizontal lines, those are in fact parallel. And then once again, the slope of horizontal lines, all right, would always be 0. All right, so we can see that they have the same slope, which means they're parallel and not perpendicular. All right, now when we look at problem 6, we can see that neither equation, all right, is in slope-intercept form or point-slope form, so we have to do a little bit of work to go find those slopes. So let's add 3x to the first side here, or first equation. So 8y equals 3x plus 19, and then divide everything by 8. All right, and we're just going to leave everything in fraction form in lowest terms. I can't reduce 3/8. I can't reduce 19 over 18, so I'm just going to leave it like that. All right, and now let's do the same thing for our second equation. So I'm going to subtract 6x from both sides here. All right, so negative 16y equals negative 6x plus 23. And then I'm going to divide everything by negative 16. All right, that's 1. A negative divided by negative is positive. 6 over, and that is a 16. If I divide the numerator and the denominator by 2, would give me 3/8 x. And then we don't really, that's a 23 over 16. And we don't really care what this value is for this particular problem. But the slope of the first line is 3/8. The slope of the second line is 3/8. So we can see that they are the same slope, which means these lines would be parallel because they have the same slope and different y-intercepts. All right, and if they're parallel, they're definitely not perpendicular. And we know that they're not opposite and reciprocal there. All right, so once again, that's how we determine if two lines are perpendicular analytically or with equations. So now let's flip our notes. All right, and let's look at what we do when, all right, two lines try this again. Let's see how we determine if two lines are perpendicular numerically. Now, once again, this is just a little bit easier than we did with parallel because we just need to see slopes. We don't care that the lines are intersect, all right? We assume that they're going to intersect because we are looking for perpendicular lines. So we just have to find the slope of line 1, slope of line 2, compare them, and that's all we need. So let's just make a quick XY table for line 1 here. It goes through the point 24 and negative 3/8. All right, so my slope, I go up 4. All right, for the change in y, I go down 5 for my change in x. So my slope of line 1, all right, is negative 4/5. And you can put that negative anywhere. So I typically just put it in the numerator out front. So 1 negative means the whole fraction is negative. All right, so let's do a quick XY table for line 2. So we get negative 1, negative 3, 7, 7. So negative 3 to 7, I go up 10. Negative 1 to 7, I go up 8. So my slope here is 10 over 8. Once again, we have to reduce to compare. Divide the numerator and the denominator by 2. That tells me my slope is 5 over 4. So my slopes are opposite and reciprocal. Therefore, those lines are, in fact, perpendicular. All right, let's jump down to number 8 here. All right, so same thing. Let's find our slopes right away. So make our quick XY table. We go through the point 5, negative 7. We go through the point 5, 10. All right, negative 7 to 10 is an increase of 17. All right, so my rise is 17, but my run is 0. Now, we've talked about this a couple of times already. So if we get that 0 in the denominator, that means our slope is undefined. And we should start to hopefully remember that, okay, this means I have no run. So that means my line is going up and down. So I have a vertical line. And once again, we can see that the x coordinates match. So the equation of that line would be x equals 5. Now let's jump over to line 2 and see what happens. Make a quick XY table. We go through the point 4, 8 and 3, 8. And what we see here is, notice my rise is 0. My run is negative 1. So this time my slope is 0 over negative 1, which is in fact 0. All right, and once again, these are special circumstances with two types of lines, right? What type of line has a slope of 0? A line that has no, all right, rise. And if I have no rise, that means I'm moving left to right. So it's got to be a horizontal line. And once again, look at the matching pieces here. The y coordinates match, and that's what the equation would be. So I have one vertical line, and I have one horizontal line. And we talked about that. If I have one of each, we know that we are going to get those right angles. So these are, in fact, going to be perpendicular. All right, one more numerical example here before we move on to graphing. And let's go ahead and jump in and find our slope of this first line. So let's make our XY table. So I get negative 5, negative 8 for my first point, and 4, negative 5 for my second point. So negative 8 to negative 5 is an increase of 3 in the y direction. And then negative 5 to 4 is an increase of 9 in the x direction. So my slope would be 3 over 9. All right, and then if I reduce that, it would give me 1/3. All right, so that's the slope of our first line. Now let's look at what happens for line 2. So I go through 1, -11, and then I go through 0, -8. All right, so -11 to -8 is an increase of 3. All right, increase from 1 to 0. I go down 1, so my slope would be -3 over 1. So m is equal to -3 over 1. All right, so they are opposites. I have one positive and one negative. They are reciprocals, so these lines would in fact be perpendicular. All right, so we've done analytical, we've done numerical, and so our final, all right, situation is graphical. All right, so we want to determine if two lines are perpendicular graphically. Once again, same process. We just need to find slopes and compare them. All right, and so when I look at my line here, I'm going to find the slope of this line that's going uphill first. And so I can see that I go up 1, 2, 3. So this has a rise of 3 and then a run of 2. So the slope of my first line is 3 over 2. And then for my second line here, I'm going to find the slope of the line going downhill. And I go down 2 and I go to the right 3. So -2 over 3. Okay, they are opposites and reciprocal. And that means that they are, in fact, perpendicular. Okay, let's jump to number 11 here. Let's find the slope of this line right here that's going uphill. And so I go up 1 for my rise, and I go over 1, 2, 3, 4. So the slope of that line is 1/4. All right, let's find the slope of our second line here. I go down 1, and then I go to the right 1, 2, 3, 4. All right, so the slope of that line is -1/4. All right, so they are opposites. One is positive and one is negative, but they are not reciprocals. So these would not be perpendicular. All right, let's do two more together here. So we got problems 12 and 13. So let's look at the slope of the steep line right here. All right, so I'm going to go up 1, 2, 3, 4, 5 for my rise, and then over 1. All right, let me try and get that back into focus for you there. Here we go. There it is. All right, so that slope of that first line is 5 over 1. The slope of my second line, I go down 1, and then to the right 1, 2, 3, 4, 5. All right, and that would be -1/5. So they are opposite and reciprocal, so they are perpendicular. All right, and it looks pretty close to 90 degrees here. All right, but you can't base it on that because it could be 88 degrees. All right, so we want those slopes to be, all right, so we know exactly what happens here. Now, once again, final problem here, we're in that special situation, right? We have a vertical line. All right, the slope of that line is undefined. We have a horizontal line. We know the slope of that line is 0. All right, and we can definitely see that we get that right angle when we have a horizontal and a vertical line. So these lines are, in fact, perpendicular. All right, so we will pick up with the conversation in class. All right, so just have your notes ready, and I will see you then.